Dear students, today I am going to teach you the basic knowledge. I am going to give you basic knowledge of current electricity. So, let us start with current electricity. Now, before I start with the topic, first of all we must know the definition of current. As all of us know or we have learned in school, current is defined as the rate of flow of electric charge. Now, how do we write it in terms of expression? We write it as current I is equal to total charge divided by the time taken. It requires to flow through a conductor. So we can write it as current I is equal to dq by dt in terms of calculus notation. Here dq is a small amount of charge flowing in time dt. dq is a small amount of charge and dt is a small time it requires to flow through a conductor. The unit of current is amperes. Now 1 ampere is equal to 1 coulomb divided by 1 second. So we can define ampere as when 1 coulomb of charge flows through a conductor for 1 second, we say that current is 1 ampere. We can also write current I is equal to L times E divided by T. Now here N is the number of electrons that flows through a conductor in any time t. So you can write I equals to NE by T. Now you can ask a question that what will be the number of electrons that will be flowing through a conductor when the current is 1 ampere. Now for that we find out how much is N. N is, you can write it as I divided by E. Now this I is the current that will be flowing for 1 second. So I we can write it as 1 ampere. Ampere is your coulombs per second divided by the charge of the electron. The charge of the electron is 1.6 into 10 to the power of minus 19 coulombs. Now if you calculate this, it roughly comes out to be 6.25 into 10 to the power of 18 per second. So per second. So that will be the number of electrons that will flow through a conductor when the current is 1 ampere. So and one last thing I would like to say is that the current is a scalar quantity because current do not follow the rules of vector addition. Now let me discuss what is electric potential. So electric potential should be defined before I come to my main part that I will be teaching you. Now what is electric potential? Now to explain electric potential, let me show you a simple way or a simple experiment. The experiment is like this. Suppose you have a big positive charge here Q. Now you know this positive charge has electric field all around it. So it has electric field all around it. Okay, it has electric field all around it. Now, if you place a unit positive charge here, any place say A, then this positive charge and the unit positive charge, what we call as test charge, will experience a force of repulsion. Now, if you want to bring this unit positive charge from A to some point B, what must be done? The amount of work that is required to bring the unit positive charge from A to B is a measure of potential. So, potential, the definition of potential is, it is the amount of work. Look, the electric field will extend up to infinity. The electric field extends up to infinity. So, if you place a unit positive charge here, and you have a place point P here, okay, and if you want to bring this unit positive charge from infinity to the point P, what must be done against the force of repulsion? So, this amount of work that is done is a measure of electric potential. Now, one thing before I start my topic, I have to explain. Now, we explain what is called the EMF of a cell. To understand EMF of a cell, let us take, again, to explain EMF of a cell, let me take a simple voltaic cell. Probably you will be learning in chemistry or you have learned in your school. A simple voltaic cell is a simple voltaic cell, and the solution here is dilute sulfuric acid, and you have two electrodes to make the simple voltaic cell, two electrodes. Okay, so this is simple voltaic cell. Okay, so one electrode is copper, another is zinc. The copper is a positive plate electrode, and the zinc is negative electrode. Now, what you do is, if you connect this electrode by means of a wire, immediately you see that the current is flowing in the circuit. I am not going to the chemistry of this. So, current will flow in the circuit. Now, if current flows in the circuit, there are two types of resistance here. One is called the external resistance, capital R, that will be outside the solution, and one will be the internal resistance that will be inside the solution. Now, the resistance, all of us know, is nothing but the hindrance offered by the wire to the flow of electron. It basically occurs because of the collision among the electrons. That's a separate subject we'll be teaching you later. But for now, you understand that there are two types of resistance in a cell. One is called the external resistance and one is called the internal resistance. The internal resistance occurs inside the cell and the external resistance outside the cell. If you connect the external resistance, immediately there is a flow of current. Now, as I want to explain you what is called the EMF of a cell, EMF, electromotive force, that is to be understood. Now, current flows whenever there is a potential difference, otherwise current will not flow. So obviously there is a potential difference between these two electrodes. That is why the current is flowing. Now, if you just place the electrode by not connecting with wires, if you just place the electrode, for example copper electrode, put inside the solution. If you put copper electrode inside the solution, immediately there is a potential difference between the copper and the solution. The potential difference between the copper and the solution is roughly around 0.46 volts. The potential difference between the copper and the solution is roughly 0.46 volts. It means copper is at high potential with respect to the solution. Now, if you put an electrode, zinc electrode into the solution, there is again a potential difference between the solution and the zinc rod. The solution and the zinc rod has a potential difference of around 0.62 volts. So ultimately, there is a potential difference between these two electrodes. The ultimate potential difference between these two electrodes, that means between the copper and zinc, is around 0.46 minus of 0.62 minus, because here zinc is at low potential with respect to the solution. So if you calculate it is roughly around 1.08 volts. That is called the EMF of the cell. So EMF of the cell exists just by inserting the electrodes when no current is drawn. If you connect these electrodes by wire, immediately there will be a flow of current. So the potential then exists between the copper and the zinc is known as terminal potential difference. In other words, the potential difference when no current is drawn is called the EMF. You just buy a battery from the store, that will give you the EMF. But once you put it inside a torch and you light the torch, that will give you the potential difference. Now, in circuit, we draw it like this. In electric circuit, we draw it like this. Here is an external resistance capital R. Here is a cell. Okay, this cell is positive terminal, this is negative terminal, just as you have copper and zinc. Positive terminal, negative terminal. Inside it is the internal resistance smaller. So two types of resistance, capital R smaller, and this cell has an EMF E. So what will be the immediately when you connect it by a wire to these two electrodes, when you connect by a wire, a current will be flowing in the circuit. What is the amount of current? The current amount of current I equals to how much? EMF divided by total resistance. This is nothing but Ohm's law. Ohm's law is V equals to I into R. So how many resistance are there? There are two resistance, capital R and small r. These two, both the resistance are in series. So we add up. So how will we write it as? We can write it as E is equal to how much? I into R plus I into small r. Okay? So we can write it as E. I into how much I into R? I is V. That means the potential difference across the resistance. So we can write it as E equals to V plus I into R. If I is equal to 0, that means what? In an open circuit, just the electrodes inside the cell, no current is flowing, then your E equals to V. This shows that just by inserting the electrode and there is no flow of current, when there is no flow of current, EMF and potential difference is the same. So I hope students, I could make you understand in brief what is EMF of a cell, what is external resistance, what is internal resistance, and what is potential difference. In subsequent classes, I will be teaching you electrical network. So thanks for now. Thank you. Bye bye.